Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
This week, we'll be talking about all things weather. And this morning, I'm joined by Paul Moore, who's a climatologist with Éireann, and he'll be discussing all the weather that we had and the different aspects of it and patterns in 2025. And also Elodie Ruelle. And Elodie is a senior research officer with Teagasc, and she'll be discussing how this weather impacted on grass growth in the past and a little bit about planning for the future as well. And also helping me on questions is Caitlin Looney. And Caitlin is a technologist with PastureBase Ireland, so she'd have a lot of facts and figures about how this grass performance appeared or didn't appear in Ireland last year. So thanks very much, Paul. Away you go. Thanks very much.
Okay, good morning. Just going to go through the climate of 2025, kind of what patterns happened during the year and how it compares to previous climate. So just looking overall at Ireland, the long series, temperature series, we can see that 2025 was the second warmest year on record in Ireland, just slightly behind 2023. And the last 4 years are now the top warmest 4 years on record, with 2007 equal to 2024. And again, it was only the second year above 11 degrees Celsius as a mean temperature for the year for the whole country. Looking at rainfall, this is the gridded average rainfall for the month for each month. So basically, each month's gridded average over the whole country. So you can see the first 8 months of the year were relatively dry, especially spring. Spring is in green there, summer's in orange, and then is a pattern change for autumn. It was a very wet autumn, which continued into January, February this year. So if I break it down by a season now, if I go into winter 2024-25, so December 24 is in there. We can see the winter rainfall on the bottom right here. We can see all the top 25 synoptic stations in the country and whether the rainfall was above or below average for the season. So you can see it was above average in most of the southern stations. Cork Airport there, Johnstown Castle, all above 120%. But a lot of the rest of the country, especially the West and the Midlands, were below average for winter. December 24 was actually quite dry, whereas January, February kind of got wetter. So we look at two particular stations here. On the top left, we've Athenry, Cork airports. And then this green line shows the average expected rainfall through the season, through the winter months. The red bars at the bottom shows the individual daily rainfall at that station through the season, and then the blue is the cumulative rainfall, so the added up rainfall as you're going through the season. And at the season, you'd expect it in an average year to follow this green line, but you can see in Athenry there is very much below average for winter 2024-25, but in the southern counties like Cork there, it got up to 126%, and this shown here as the blue goes well above the green line here. So just to show you that chart, because it'll come up later on. Temperature for winter 2024-25, again, the 25 synoptic stations on the top left here shown whether it's above or below average. So we can see all the stations were above average temperature-wise for winter that year. And then Mullingar, we just zoom in on Mullingar here. Everything above this line, the red, is above average. Everything below is below average in blue. So through the season, December, January, February, you see December was mostly above average, but we had a very cold spell at the beginning of 2025 for the first 10 days, where we had an icing day. We had snow lying on the ground in the southwest, South Midlands and west for up to a week in some places. But then it got milder for the second half of January, and February is milder than average. So overall, it finished a good bit above average for winter. And one of the main events through the winter was Storm Éireann on the 24th of January, where we saw record wind speeds, both in gust and 10-minute wind speeds, at Macehead, County Galway, to 184 kilometre an hour gust and a sustained 10-minute wind speed of 142 kilometre an hour, which is hurricane force. And 2 stations reached hurricane force during that storm. 4 stations reached violent storm force, and 8 stations reached storm force during that storm. For us, quite a very vigorous depression that came close to the northwest coast. If we look at spring now, so this chart on the left shows the average if a geopotential height through the middle of the atmosphere through the whole of spring. So where the deep red is where the mostly high pressure anomalies are. So if it's very deep red, you can say that there was high pressure dominated in this area through the whole of spring. Where it's blue, you can say low pressure dominated. So you can see over the Iberian Peninsula, low pressure dominated, but over us, just to the north of us, we had a very dominant high pressure signal there and a lot of slack easterly winds and a lot of sunshine. So it ended up being the warmest and sunniest spring on record in Ireland, 2025. And if we put over the temperature anomalies there compared to the 1991 to 2020 long-term average, you can see pretty much all of Ireland is between 1 and 2 degrees above average. And so is most of Europe, especially in Eastern Europe for spring. So it was the warmest and sunniest spring. You can see over the Iberian Peninsula, it's more average or below average because the low pressure was there and it was quite wet there. So the top 5 warmest springs in Ireland since 1900 have occurred since 2017, reflecting the trend of warming temperatures. If we look at rainfall during spring, again, the top 25 stations here, you can see all of them are below average, and some of them, especially in the south, are well below average, 57% there in Sherkin, Moore Park, 67%. And on the right, these maps show where the dry spells and the absolute droughts were. So the definitions are there. They're 15 consecutive days for dry spell, with less than 1 millimeter, and 15 consecutive days where no day has more than 2 millimeter or 0.2 millimeter is an absolute drought, and then a partial drought here. So they're called climatological dry periods, and there's 3 different types. So there was 20 stations had dry spells during spring lasting between 15 and 27 days. 11 stations had absolute droughts and 2 stations had partial droughts, and they're spread pretty much evenly across the country. So everywhere had these dry spells during spring, but that wasn't the full picture during spring. So we break it down into these 3 stations: Athenry, Dublin, and Moore Park across the country. We can see there was dry spells before and after this kind of wet period in April, which obviously would have helped with the growth. You can see there was a 10-day period in April where actual low pressure came in, and we got a good bit of rain during that period. And there was dry spells in a lot of stations before and after that period. But that would have prevented a more serious drought happening during spring 2025. Another feature of spring with the marine heat wave during May. You might have seen it on the news. So especially to the west and south of Ireland, with those slack easterly winds coming off the continent, coming off Ireland, you can see on the global picture, everything in red is above average, everything blue is below average, and just to the west of Ireland stands out there as the most anomalously warm sea surface temperatures across the globe. So that's higher than average, not like the warmest. It's just higher than average. So that was a big feature during May, and these warm sea surface temperatures, if not as high, continued through the summer months. So in the summer, finished the warmest summer on record since 1900 in Ireland as well. You can see the top 10 warmest summers there on the left on the chart. 2 previous warmest summers were 1995 and 1976. A lot of people remember them very fondly as hot and sunny summers. So, but this summer in 2025, overall had warmer temperatures, mean temperatures. This means the nighttime temperatures and the daytime temperatures averaged. So basically the cause of this summer being the warmest on record is not the same as 1995 and 76. So the different, what led to the record-breaking summer was the dry soils coming in from a dry spring. So there's less evaporative cooling. The marine heat waves around our coasts, the above average sea surface temperatures continued around the seas around Ireland, which kept the overall temperatures and nighttime temperatures higher. And the nighttime temperatures, because it was cloudy, it wasn't particularly sunny summer. the nighttime temperatures and the sea surface temperatures, or the cloud and the sea surface temperatures, kept the nighttime temperatures very high during the summer, which brought up the mean temperatures for the summer. Now we just examined this quote here: the added heat in the system and continuous background warming due to climate change can now transform an unexceptional season into a record-breaking one, due to the baseline conditions steadily rising. We just delve a little bit deeper into that. We look back at the three warmest summers in Ireland: 1976, top left, 95, and 2025. And this is the same as the chart before. It shows where the high pressure dominated through the whole season. And you can see in 1976, over in just the north of Ireland, it was very anomalously high pressure there, more low pressure over Europe. In 95, again, it was anomalously high pressure over Ireland through the season. It doesn't mean it was high pressure all the time. It just means on average, it was higher than average pressure in this area through the whole season. Whereas we look at 2025, the dominant high pressure was to the south of us. That's where the heat domes were over Europe, in the Iberian Peninsula of France, and in southern Europe. And we were kind of in between the high pressure and the low pressure to the north, and we had a mostly westerly airflow, which brought a lot of cloud during the summer. So that's the different setup for the three different warmest summers on record. And if I just superimpose the temperature anomalies as compared to 1991, 2020 averages over these, we look at 1976 in the top left there, and I put the anomalies there. You can see how Northwest Europe stands out as the warm area during 1976, and a lot of the rest of Europe is cooler than the 1991, 2020 average, as you'd expect, because it was a cooler climate back then. But you can see that it was the Northwest Europe where that high pressure anomaly was, whereas it was much warmer than average. And in 1995, if I put the temperatures over there as well, you can see Northwest Europe stands out, especially Ireland, as the most above average temperatures during that season. The rest of Europe is either average or below your average, except for Eastern Europe there. But now if I superimpose the temperature anomalies for 2025, you can see the vast difference overall is that there's a lot more red and orange on the chart. So most of Europe was above average, apart from just central Eastern Europe, and a lot of Western Europe and Southern Europe. A lot of countries had their warmest summer on record, including the UK. And so we weren't alone there because of the background temperatures rising, bringing up the overall temperatures. Now we look at rainfall for the summer months. It was around about average overall, 98% for Ireland of the 1991-2020 long-term average, but it was very varied across the country. If you look at the stations here down on the bottom right, about half stations were above average, half stations are below average. Some in the south, like Moore Park there, Cork Airport, were quite a bit below average. And then some in the west, like Athenry there, 160%. So we break that down. Moore Park's one with the driest stations there. You can see it did have bits of rainfall through the season, but it didn't add up. But by mid-June, it was below average, and it stayed below average through the whole summer. Whereas in the west, there was quite a bit more rain on a daily basis through the whole summer in Athenry, and it stayed above average through the whole summer for rainfall, and it finished above at 160%. So there's quite a varied rainfall across Ireland during the summer. Now, if we look at autumn, there was a pattern change in autumn where, again, there's blue over us now for autumn. This is over the September, October, November, and the average G potential height. So we had blue over us now. So we had low pressure dominating during autumn. We had a south shifted jet stream. We had blocking high pressure to the east. So the low pressure systems were coming up to Ireland, and a lot of them were stalling over to the south of us and sending out rainfall north. So we finished with the fourth wettest autumn on record, going back to 1941. And we finished with 134% of the 1991 to 2020 long-term average. And that was across the whole country, but you can see there that in the south and east, especially, got a lot of rainfall because of those low pressure stalling to our southwest. So we see Johnson Castle had 163% of its autumn average. Mount Dillon there as well, 156. Sherkin Island, 156%. Everywhere is above average, but some stations in the northwest finished pretty close to average, not too far over average. but the concentration of rainfall was definitely in the south and east for autumn. And then we just look at the temperatures for autumn. It was a cooler than average September, but October and November were warmer than average. And all stations finished above the long-term average for autumn as well. So it finished the 20th warmest autumn since 1900. And of the top 10 warmest autumns, 7 have occurred since 2001. Now, the Climate Change Advisory Council released their latest report, Our Changing Climate in 2025, which has a lot of disinformation in it and some global and European information at the beginning as well. Just to quickly look at winter 2025-26, cut December obviously still in 2025, and you can see the anomalous low pressure to our southwest there during winter. Now, December itself was actually quite an average month for rainfall, and it was above average for temperature. But January and February saw this dominant low pressure to our southwest, and we had stalling low pressure systems with the south shifted jet stream again. And we can see in all the stations here that the south and east of the country, Dublin Airport 172% of its winter long-term average, Johnstown Castle 174, Phoenix Park 172. So the south, east and Midlands had a good bit above average, whereas the northwest, Finner there, Belmullet had below average rainfall again during the winter just past. Now there was 3 attribution studies. So there was rapid attribution studies carried out called the Was It Us project, and it was sponsored by, funded by the EPA and Éireann, and some Éireann, some of us were involved in it with the Icarus group in Maynooth University, and we did 3 studies during, 2 studies during 2025 and 1 study at the beginning of this year. And they looked at how climate change was attributed to basically the events that happened in Ireland through the year. So if you look at the top 10 warmest summers on record there, see 3 of them are already in this decade, and we're in just over half this decade, and 2025 being the warmest. And they found that through statistical analysis that nighttime temperatures that made 2025 the warmest on record was now 40 times more likely due to human-caused climate change. Another one they did was the Storm Chandra event, the 2-day rainfall that led up, because Chandra was just stalled to the southwest for about 7 days during November. And it sent up weather fronts and from the south over the south and east got especially hit, and there was a lot of flooding caused by this. So the 2-day weather event rainfall caused by Storm Chandra increased by nearly 12% in these counties compared to pre-industrial, what it would have been in pre-industrial climate. And rainfall associated with the 30 days leading up to Claudia has increased by 7%. And then Chandra was in January, and they did another study there, rapid attribution study, and they found that the 7-day accumulated rainfall had increased by 8% in comparison to cooler pre-industrial climate, and is now 3 times more likely to occur. So when we do get these events where we're stuck under low pressure, we're getting dominating our weather, and we're getting a lot of rain, the more rain can fall now because the atmosphere can hold more moisture, and so we're likely to have more heavier rain during these events. And then just to point out that there's a citizen science project that some of my colleagues are involved in, and if anybody wants to get involved or anyone knows wants to get involved, that we can, all these handwritten observations going back into the 1800s, we want to get digitized, and we want to make especially for rainfall, a rainfall network going back pre-1900 to see how our climate is changing even more. And that's everything from me now.
That's great. Thanks, Paul. Elodie, whenever you're ready. Thank you.
Okay, so I'm just going to speak a bit more about grass growth now, and basically the consequence of that weather we just heard about on the grass growth in 2025, and then look a bit more into the future also. So what I want to say first is we need to all realize that, comparing grass growth is not the same than comparing weather, because obviously grass growth is impacted heavily by the weather, but not only by weather. So obviously fertilizer will have a big impact. So if we remember 2023, for example, way less fertilizer was used. So that will have a big impact on grass growth, even nationally. But then if we look a bit more at county or even farm level, farmer management will have a big impact for why grass growth is different from one year to the other. There could be new species in the grass, there could be more reseeding, there could be a lot of real impacts which will link to grass growth. So I just want everyone to remember that before I go further away. And obviously everything interacts. So if we think about this spring, for example, it has been very wet, so fertilizer would have went out way later on compared to usual. So, everything is a big interaction when we speak about grass growth. So it's weather, massively important, but other factors do interact. So if we look, so it's going to be mainly from PastureBase Ireland, so but all farmer data here, so everything which has been recorded by farmer. That's your annual tonnage or annual grass growth per year from 2018 to 2025. You have then the 10-year average and 5-year average. And 2025 was a fairly good year. We were back at our 10 and a good bit higher than our 5-year average after a good few not great year, we'll say. So 2024 was fairly cold and wet, and 2023 was, a bit drier also, but also less fertilizer went out. So that's what impacted all that grass growth. So that's the annual tonnage. If we look a bit on the curve, the grass growth curve during the year, so the darker line is your 10-year average, and the lighter one is 2025. So what we can see here is an earlier start in the spring. The peak was earlier than usual also in average, a small decrease. So that's the average for the country there. So it's all farm which put data into PastureBase. So a bit of a, probably due to water deficit there, and then slightly better autumn than average. And when I will show you a bit more about climate change and the projection, that's actually very typical of what we would predict, which is higher growth in spring and in autumn, and then a bit more variation in the summer. If we compare back to other years, so I did say 2024 was a bad year, and 2024, so that was 2025, 2024 added to it, overall lower for the full year. Like it was a bad year all around in terms of less growth. And if we want to compare to 2022, which had the same annual growth than 2024, so that's a new curve which is going to appear. If you see that, so that's the same cumulative growth, but for different reasons. So it's mainly like your drought or water deficit anyway in the summer would have had a big impact on that decrease of growth. And then we could put all the data there, but that just to show there's big variability between year, even at the country level. And obviously our big drop there was 2018. Okay. If we look a bit more, so it was just what I've shown you there was the average for the country, but obviously, especially last year, there was a big variation within county. So there's a curve there or a line there because there has been this year very clearly way less, water deficit in the south and southeast there below that line than the other part of the country had a fairly good year in terms of grass growth. And that was due to the rainfall in May, June, July, even though the total rainfall for the year was fairly high. So if we go back, so that's the annual, it's hard to see much on that, but if I did do some curve for the county level, so if we look at, so in black is 2025 and in gray is the 10-year average again, all pasture-based data again. So that's the grass growth for Cork, Tipperary and Wexford. So you can see like Cork had really a tough summer, didn't reach the normal level there. And that was water deficit. Now Cork is fairly big, so depending where you were in Cork, you might have had a very good year or not a great year, but even in average, you can see there was a problem there. Tipperary wasn't too bad, but still at the end did had that kind of water deficit there, and Wexford was fairly badly impacted. Once again, big variation between farm, but we could see that. If we look at other county, Clare, Limerick, very close to Tip, obviously, and so on, and Meath, they had a very different year. You can't really see any drop in the, summer months and so on. So for those county, it was a very, very good year. So it's just important to realize that, the variation between county, and that was mainly due to the rainfall in the summer. And I'm not going to go to farm level, but, we do know that rain did avoid some farm, and some farm, the neighbor might get rain and the other farm wouldn't get rain. So there is getting more and more variability in the country, and that will keep going in the future. If I go now into my future slide, so that's simulation. Now it's not farmer data anymore, and we use a translate data from Éireann to try to predict the annual grass growth in different global warming scenario. So it's not +3 degrees for Ireland there that I'm showing you. It's global warming, so Earth warming of +3 degrees in average. So that's the baseline scenario where in average it's growing 12.4 tons. 1.5 global warming would mean an increase of grass growth by 0.44 tons. And another, if you go up to 3 degrees, it keeps increasing. And that's mainly due, well, I will show it after actually, so I'm not going to say that too much. But if we just stop there, climate change looks positive because there is more growth happening. But if we look a bit more on when that grass growth is happening, so we look at monthly now, still with the translate data, and I'm showing you the difference between the baseline scenario, so this map, and the difference between the 1.5 map basically and the baseline scenario, okay? So it's one minus the other, and that's the difference in kilogram of dry matter per hectare per month, okay? Anything which is blue, green, don't know how you call that, means an increase in grass growth, and anything which is more yellowish brown means a decrease in grass growth. So for all the spring months from January to May, October, November, December, everything which is predicted to happen is an increase in grass growth for those months, and that's mainly due to an increase in temperature. So that's a bit what we're starting to say in fairness. Increase of temperature, slightly increase in grass growth, and really the increase for April. But then if we look at the summer months, then there is a decrease predicted in grass growth. So that's for the 1.5 degree warming. And if you look at the localization of that decrease, it's not exactly what I was showing on the other map, but, you know, the southeast is the place which is hit the most. So, you know, we're starting to see those kind of signal at the minute on what's happening on farm. If I show the same map with 3 degree minus the historical, then it's the same story, but just everything becomes very darker. Now the color are a bit dramatic. You know, brown does not mean, pure brown does not mean that it's going to grow 0. It means minus 400 kilogram of dry matter for the month of August. So that's kind of minus 14 kg of dry matter per hectare per day. But it's still a big decrease there. And a very bigger increase for April because those temperatures are going to get higher. And we did look at why was that grass decreasing. It wasn't directly due to the increase in temperature. It was due to the lack of water in the soil. So obviously higher temperature would drive evapotranspiration, which would drive the decrease in water. But it's not like too high temperature for the grass to handle. It's just if there was plenty of water in the soil, it would keep growing. So that's really lack of water there, which is happening. Okay, so that's just to show that what's happening this year and the last year and this year is fairly much in line with what's predicting to happen in the future. Okay, and very quickly, my almost last slide is what can we do about it? So there could be a slight increase in grass growth. That's what is forecasted. But let's remember, well, I didn't say, but it's all business as usual. So it's considering that you can actually put fertilizer out at the right time and so on. But in reality, all grass growth is increasing in the projection there in March, April, February, which is also associated in the translate data by a possible increase in rainfall. So if it rains too much and trafficability is bad, we won't be able to put fertilizer out. So which means that increase in grass growth may not happen if the fertilizer cannot go out. How can we use that extra grass? Because if there is more rainfall and so trafficability will be poor. So that's where we need to be able to use that grass without poaching all the paddocks. So that's where on-off grazing, you know, putting your cows for 3 hours after each milking out and then bring them back indoor will be very important. And for that, you need very good farm infrastructure. So that will be more and more important in the future. After that, so there's an increase of variability in what's projected to happen, especially in the summer, and that's increase of variability between the country, well, inside the country, but also every year it's supposed to be a very different year from the year before. So, what can we do? So, for example, like more diverse sward should be able to, if we can maintain them in the sward, they should be able to help us with water deficit because they're supposed to be more resilient in terms of water deficit. But I think we need more research on that to keep them in our swards. Then obviously, if there is more summer drought or summer grass shortage, we'll need more silage, and we'll need better quality silage than what we have at the minute, because the silage will be fed to your lactating cow and not more to your dry animal in the winter. So that's where we will have to become very good at doing very good silage and to have a big stock of it to compensate for a fairly bad year in terms of grass growth. Same, I don't have it in the slide, but if there is more and more rainfall happening in the autumn and the spring, we probably will have to keep increasing that slurry storage, because that means we'll have to sometimes house the cows more. Even with enough grazing, you would get more slurry in. So we'll have to increase that slurry storage. Measuring grass, so we say more variability again. The more you measure, the more you're able to react fast to what's happening in front of you. So grass measuring, very important, using tools such as PastureBase Ireland, very, very important. And then obviously that's more on our side, but can we do more tools for you with the grass growth prediction and things like that to be able to look ahead instead of just working on what's actually happening right now, but trying to predict what's going to happen next week or for the next 2 weeks or even months, maybe at some stage. And the last one will be, it's very important to have the right or the appropriate stocking rate for the grass you can utilize, because if you overstock, both kind of increase of variability between year will become more and more challenging to handle. So if having the right stocking rate for the grass you can utilize, and I'm saying utilize and not grow, because if you can't grow grazing and you have a lot of grass, it's not that useful. So right stocking rate, very, very important there. Okay, so my conclusion, I don't have that much to say, but on average, 2025 was a good grass growth year for most of the country. Not every year, it has been very bad for some farm, but in average for the country, it was good. The rainfall was very localized in parts, so the summer variability is currently increasing in the country, and it will keep increasing. Autumn and spring growths are also increasing at the minute, which is to be expected when we look at the future climate, and it's because temperature are increasing, so that's helping our grass to grow more. And that's in line, as I say, with the climate projection. And I guess the 2026 spring, which is so wet, is also in line with what's predicted to happen. That's all for me.
Thanks very much, Elodie. Thanks a million. Nice. We move ahead with the questions. I can see there were a number of queries there to do with citizen science and the recording of weather, and I know that Paul has sent some answers to these, but I just might get Paul to comment on them, and we'll put the link in the chat just so that it's visible to everybody who's actually on. So Paul, can you just comment on that side of things, please?
My colleague started up this because there's a lot of handwritten records, especially for rainfall from volunteer stations going back into the 1800s, that need to be digitized. And so the Citizen Science project is to get everybody involved. You get on to this website or app, and each observation is double quality control because 4 people are doing each one. And then that goes into the records, and then we have a better look at how the rainfall has varied over the country, going back 100 years, going back even into the 1800s, if we can get all these handwritten records, which there are thousands and thousands of. So it's a project that's just started to get anybody who has an interest in it get involved. And as you say, you can just go to the website there, irishweatherrescue.ie, and find out a bit more about it.
Okay, Caitlin, if you want to come online there, I see there's questions, more and more questions starting to come in. As often happens, the questions only start to get going at the end of the presentation. Is there anything there do you want to just put to Paula or Elodie at this stage?
Yeah, so I suppose we've got a question in there from Dara, and he's just wondering, are we more likely to see warmer, milder winters going into the future?
Yeah, so the projection for winter is that it is going to be warmer, it'll be less cold spells, but it'll also be wetter, especially winter, that it's going to get progressively wetter as a warmer atmosphere can hold more moisture. And as I said, if we get stuck under these low pressures for long periods, they will drop more rainfall now. And if we get warmer into the future as we are, they'll be able to drop even more rainfall then. So the projections is warmer and wetter for winter.
Great, thanks a million. And we've got a question as well, Paul, on any comments on the effect of wind as well in the future.
Yeah, I didn't go into the storms too much there because I just wanted to stick to temperature and rainfall. Didn't have enough time, but yeah, we have had a number of storms, as was mentioned, and the potential for the future is that we have more energy potential in the atmosphere because of the warmer sea surface temperatures, the warmer atmosphere, more moisture. There is potential for storms to get stronger. Now, it's not as straightforward as that because different research shows that jet stream moving more north and different research shows it moving south depending on what happens. So the amount of storms is uncertain if we're going to get more or less, but the projections are that when we do get them, the potential is there for them to be stronger and definitely to drop more rainfall.
Okay, great. Thanks a million, Paul. Elodie, a question for you on the lower rainfall and selecting grass pasture for the summer and how is that going to impact it?
Yeah, I'm not fully sure. So there is research going on around multi-species and there's loads of literature on it. So like in fairness, there isn't that much work done on adaptation in grassland. I think there's different reasons for that. One is, Ireland is amazing about, we're very good at grazing and so on, and most of the other country are not doing it as much, so there's less research in other country. And also a lot of the adaptation strategy which are developed in other country are not really relevant for us or not yet, or I don't think relevant for the next 50 years, because in other country, when what we call a drought here is a very good summer for grass growth in loads of European country at the minute. But to go back to the multi-species of different species, if you do look at the literature, it's your one adaptation strategy for grassland for when you have a water deficit and things like that. But at the minute when it works on plots, very good, and I don't have the, I wouldn't be able to give you the right mix of whatever which work on plots, but all our experiment at the minute when we put it on like system experiment and on farm, we don't see yet that same drought protection or drought resilience. So we need to know what's happening differently between the plots and the farm to know why it's not working. So it could be, or not working as much anyway. So it could be grazing. It could be we need different farm management to make them work better. I don't know. Yeah.
Caitlin, just your work as a technologist on the pasture-based, do you come across or do you see farms with mixed species swards or that, or how are the farmers finding them with regard to, drought resistance or whatever the case may be?
Yes, I suppose on the application, we have the option to, when you're reseeding and you are putting in these multi-species swards, you can select them so we can see them through PastureBase Ireland. But it is very varied. And, a lot of farmers have only incorporated maybe on one paddock on their farm. So, to compare, it's very similar to what Elodie said on the farm system studies. Potentially, anecdotally, farmers had seen maybe better few days, but we're not seeing what's replicated on plots on farms across the country.
But that could be because we're not sowing the right species either, or we're not managing them. There's a lot of reason for that. I do think we need to keep pushing and finding the right, the right mix for our system, but we're just not there yet.
Yeah, there is lots of research going on within the organization on various different mixes and that. So
yeah, hopefully we'll have a better answer soon.
Yeah, do you want to go ahead there? You can pick another one there, Caitlin, if you like.
Yeah, so I suppose, Elodie, while you're on, there was just a question there on agroforestry. You mentioned trafficability and how agroforestry potentially might play a role in increasing trafficability at the shoulders of the year. And that's offering protection in terms of shelter and stuff to livestock. And I think that's more looked at on the continent where they have experienced these drier summers. Do you think there'd be a place in Ireland for agroforestry, or have you seen it in any predictions across the continent?
I'm really not an expert on that, so I'm not sure I can properly answer that question. Like it technically could work, so yeah, and it probably would, bringing shelter in the summer also, if we do get very warm summer, but then I'm really not an expert on that, so I don't know. I don't know if you know
Yeah.
more than me, Caitlin, but or Cian or anyone.
No, I've just seen, bits of it across Europe more, so it's really not been taken on here, even though there I think maybe more studies across Ireland need to take part or be done in that.
But the funding structure of it changed slightly lately as well, which made it more
So
attractive, I think, as well.
there might be
So
more interest. Yeah.
there's more interest, and anecdotally, at least, we have no research to back it up, but they do say that it does impact on trafficability, certainly on wetter soil. It can improve them, all right, but we don't have science or certainly research to back that up. And Paul, I'm just wondering, across the years now, more recent years, the last 10, you mentioned, a number of times there about how they've been warmer, we're aware of these trends and how it affects temperature and other weather events. I just wonder, in general, is rainfall falling steadily? Or is it now, what proportion of it is made up by exceptional events? Or is it generally steady as it has been?
I would say no. There seems to be more of because the north is warming faster than the south. Tends to be periods where the jet stream meanders north and south more, and the patterns get stuck for longer. Some research has shown this to be the case, especially spring, summer. So we are getting the likelihood of kind of longer, drier spells if this is the case. And when we do get the wetter spells, because there's more rain, more moisture available in the atmosphere, because it's a warmer atmosphere, it can hold more moisture. The sea surface temperatures are warmer. Then the rainfall is heavier now. It's so in the past maybe it might have been more days of rainfall, but much less. But now we're getting more extreme rainfall events. So the rainfall is heavier over a shorter period of time, and that's likely to continue as well.
Thanks, Paul. And just leading off that, then, Elodie and maybe Caitlin as well, is you mentioned it on your last slide is how those if we do get these pockets of much more exceptional rain at whatever time of year is how that might impact on the management or what needs to be done at farm level. Do you want to just make a comment on that, Elodie?
Well, that was a bit, what I said, like on-off grazing will be one of your things which will help you. Having less time at grazing, that will help protecting that. After that, look, if it's too bad, you will have to go back indoor for a while, and that do mean that, it will mean more slurry going in, and so you will have to increase your slurry storage and so on. So I think that's the two main one. And the variation between years seems to be increasing a lot and will keep increasing a lot. So your main things will be, you're going to have a very good spring where you can probably go out the 15th of January with no problem for some reason, or later on, you will be able to go out no problem. But, the year after, you might not be able to go out before April or something. I'm putting extreme there, but that will be the reality. So that means you will have to bring in the system flexibility to be able to manage those two extreme years, which could be one after the other. I think, I don't know if you want to add anything, Caitlin, but
yeah, I think you're right there. The flexibility is the most important part, and as you said, measuring your grass and seeing where you can go, where it's trafficable, what opportunities you can take to graze, and then when you can't, you're just in and you're ready for that as well with your good silage stocks and your correct slurry storage.
Okay, another one for you, Paul. There's a couple of, well, it's probably a combined thing, really. It's again the questions around this winds and whether high winds impact on growth. Now, is there a variation on when the storms might land? I know it's hard to predict that, but I assume at certain times of year it's going to increase wind chill. At other times it might be less so. There are a couple of questions around that. I don't know. Do you want to comment really on a trend with regard to when these storms are landing? Are they very sporadic? And then either Caitlin or Elodie, if you just want to mention a little bit about temperature, about air temperature as opposed to soil temperature and grass growth.
Yeah, there's different kind of periods, but the storm season goes from September to August, but the majority of storms come during the winter months. November, December, January, February. But then there's a period in August, September where we can get tropical systems coming up from the south, whereas that's the peak of the tropical storm, the hurricane season in the Atlantic. And depending on the patterns, we can get these recurving and coming up towards us, not as hurricanes because the sea surface temperatures aren't high enough, but they can transition into very strong mid-latitude storms if they're coming up. They can move further north now because the sea surface temperatures that they need to survive are further north. So the transition to mid-latitude storms is happening closer to us. That means they can be stronger when they hit us. So going forward, as this continues, sea surface temperatures going up, especially in August, September, October, even have the potential to get stronger tropical systems coming closer to us, and transitioning into mid-latitude storms. So depending on the season, like we've got an El Nino coming up, they're not expecting an active tropical season this year because El Nino suppresses storms in the Atlantic, tropical storms. But when we do get periods like when there's a La Nina and there's a lot of tropical storms, they can move further north, closer to us, and give us stronger storms during that period. And then the more traditional mid-latitude storms, based on the colder temperature to the north and the warmer temperature to the south, clashing and strengthening the jet stream over the winter months. They're likely, that's more over the winter months, and that's when we see the most intense storms for us. And as I say, because there is more potential energy there, then these storms can get stronger. And then if you get a really strong cold front crossing as wind chill we're talking about, you can go from very, very warm or air mass to much colder air mass very quickly, and that could with a wind direction change, and that could probably have an effect on them, as the person was saying there, the wind chill factor.
Okay, thanks, Paul. And just leading on from that, either Elodie or Caitlin, do you want to just comment then on the impact of wind chill as opposed to soil temperatures on grass growth, and what's critical to get grass growth?
Yeah, we don't have that much research on it. Like, I think I do remember,
is that I understand that wind chill comes into it to a certain extent, but like as regards temperatures is what's critical for grass growth with regard to the research, temperature wise.
It's usually soil temperature we always speak about, but we did had some year where soil temperature looked still okay and growth was slowing down. Now, like, I'm a modeler and we don't take that into account. So I know the prediction was maybe a bit high at that stage because we are just looking at air temperature and soil temperature, and not really the wind chill wasn't taken into account. And we could see the grass growth being lower at that stage. So I do feel there's a good bit of impact there that I don't fully understand. The second thing which can happen a good bit with wind also is if you start to have a drier time, it will dry your ground even faster. And so that will, that will bring in your water deficit even faster, so bring you into drought even faster. So that's something which is important to realize also. So sometimes it's good because if there's too much water, it's going to dry your soil also, but at other time it's going to be a bigger problem.
Caitlin, there's a question there. Do you want to address that just or pass it on with regard to different fertilizer types?
So I suppose there's a comment in on using synthetic slow release or liquid fertilizer depending on the year. So I suppose if you're using fertilizer, it is, as Elodie said, dependent on trafficability in the spring. So if you can't go out with a tractor, you're not going to be able to spread any type of fertilizer at that point. And I suppose maybe what they're referring to is that you could spread, say, if you got the opportunity to spread in February, that you'd spread for the rest of the season. But look, if there's a lot of rainfall coming, the other types of fertilizer, they're still not going to stay in the ground. We're looking at fertilizer to spread for the predicted grass growth that's coming in the next 2 to 3 weeks, and that's what we're applying that fertilizer to supply for those. So if we're not looking for a longer release, because there's potentially, Elodie, you can comment on it, but potentially there'd be a lot more or nitrogen available in those fertilizers for leaching, and that's not the scenario we want. we want to spread fertilizer for the grass that's growing, you know, in the next 2 to 3 weeks, not for a longer term. We don't know when that's going to be taken up, you know.
Yeah, you happy enough with that, LD? Yeah.
Yeah, I think so. I like just, and if it takes the opposite around drought or anything, like some people might be thinking, oh yeah, it's liquid, so it will bring a bit of moisture into my ground. If you're in drought, just spread nothing, because it's never gonna give enough, it's never gonna give enough moisture for your soil to be able to give water to the grass. So it just in case that was part of the question there, I don't know. But yeah.
I see a question has come in from one of our specialists there, to Paul. How difficult is it to separate the impact of greenhouse gas-induced global warming from cycles such as El Nino or the North Atlantic Oscillation Index?
Well, first, on overall global warming, the North Atlantic Oscillation doesn't really affect whether the overall global warming goes up or down, because it's just shifting the warmer regions around and the colder regions around. Whereas El Nino and La Nina, because it happens in tropical regions, it can affect the global temperatures a good bit. So during an El Nino, and especially the 6 months kind of after, because there's a delay, you can get a spike in the global temperatures going up, and during La Nina you can get it going down. But you can take out these La Nina ENSO kind of effects out of the thing, and you can see the curve is the overall background warming caused by human-induced climate change is there, and it's still going up. So you have these individual little spikes on this overall background curve going up because of human-induced climate change. So you can take out the kind of the noise of El Nino, La Nina, and still look at just the overall change, and it's still, fairly starkly going up.
Thanks, Paul. Caitlin, have you got one there?
We've got another question on, because of milder winters, can we grow more grass over winter, in terms of we'd normally be housing cows and we'd have a set targets for when we're closing on farm, but can we grow more grass over this winter period?
So yeah, I would say definitely that's what's going to happen in the future. Like, once again, variability between years. So it's not because this year we might have a cold winter and grow no grass, and it's not the trend. Like, there's going to be a big variability. I think in the future we will grow more grass in the winter. So maybe that means we'll have to look again at our autumn, what is our closing target and so on in the future. About grazing a bit more in the winter, well, we need to remember what we just say about more rainfall and so on. So we might, grow more grass, yes, but probably won't be able to graze it because it's going to be too wet. And we need to remember also that if we think a bit more on some other things such as water quality and nitrogen leaching, grazing in December, if it's very wet, would mean that more urine patches is going back into the soil, a very dangerous time of the year, and that could induce, more nitrogen leaching. I've seen a question kind of just after around was it more mineralization in the winter also, or something like that? Yes, that's what's forecasted also, to get more mineralization overall in the future year due to the increase of temperature. So that's what's forecasted too, yeah.
Paul, is the variance, so just with regard to that flood mitigation, is the variance between stations, is that fairly consistent? We could see some of them there where, they were at 175% of rainfall, and others were down nearer to 75, 77, 78, 79. Is that typical, or has that increased, that diverse, what would I say, the difference in heavy rainfall events between different parts of the country over time?
Yeah, that would be increasing. I mean, it's more typical in the summer months when we get more convective rainfall. So you get heavy thunderstorms breaking out in one area, that might drop a lot of rainfall in one area or in one path, and then a few kilometers or whatever down the road, you don't get any rainfall from that particular convective event. So in summer as well, when a lot of our rainfall comes from convective rainfall, that's where you get the big differences between the stations. Like some can get like huge amounts in 1-2 hours, and then down the road they can get nothing. So and that goes in ties with with the rainfall events, that these actual systems now can drop more rainfall. So then if you're getting more of a disparity, then because the places that are getting rain are getting more rain, but places that are not getting any are still not getting any. So it can increase the divergence between the stations then.
That's great. Well, look, I think we are just coming up to past. I'd like to thank Paul and Elodie for their presentations, and also Caitlin's assistance there on questions. We had some other suggestions based on some of the questions that come in about future speakers for some of the topics that were covered here, and perhaps that we couldn't address here. You know, the expertise wasn't in the room, but let's bring it in the room. And we're always looking for those suggestions. So thanks to the people who suggested those bits and pieces. We will look into that for future webinars. Next week, we will have Brendan Horan on. And again, another topic that actually was addressed slightly here is the multi-milk project, and looking at sword species diversity and how it impacts on dairy systems. So that should be a very interesting thing, and not unrelated to what we looked at today. Thanks a million to everybody. Thanks to my panel here, and for our group in the background to make this possible. Talk to you next week.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.